All right, here are solutions for quiz 7, I guess, for Math to 11. This is operations in different bases. So we're going to do some multiplication first and then some division. But the challenge is to perform these operations using the given algorithm in the base that's provided. So up here it says hex, that means we're in base 16. And when we're in base 16, or any base greater than 10, our standard is to let A represent the base 10 concept of 10, B 11, C 12, D 13, E 14, and F 15. And note that that's all we need because in base 16 we need digits from 0 up to 15. Just like in base 10 we need digits from 0 to 9. Okay, so we're doing some multiplication here, but specifically with the intermediate algorithm. So what I will do is I'll write A23F, probably a bigger number than I needed to use for this problem, times 32. And what I'm going to do is I'll multiply 2 times F here. And remember, F is 30. So, sorry, F is 15, as it says right here. So 2 times 15 is 30. So what I got to write, maybe I'll even keep track of what I'm doing in each line, is 2 times F will go on this first row. Since it's 30, the way I write that in base 16 is I think about 30 is one group of 16 with 14 left over. And the way I write 14 is with an E. So I get one E here. And then I continue. 2 times 30 would be 60. No carrying or anything weird going on there, so really I don't even notice that I'm in base 16. 2 times 200, again, is relatively straightforward. I get 400. And then 2 times A00, 0. I have 3 zeros after the A. Is, well, let's see, let's take care of the 3 zeros first. 1, 2, 3. And then I got to figure out what 2 times A is. Well, A represents 10, so 2 times 10 is 20. But the way I write 20 in base 16 is that's one group of 16 with kind of 4 left over. That gets me here. And now I want to do the same thing, except instead of multiplying 2 times each digit up here, I want to multiply 30 times each digit up here. So I'll do 30 times F. Well, it ends in a 0, so there's that 0. 3 times F is 15, so 3 times 15 is 40, is 45. And 45 in base 16 is 2 groups of 16. That's 32 of the 45, which leaves me with 13 more. And the way I write 13 is with a D. And then I got 30 times 30. Got 2 zeros to write. There they are. And 3 times 3 gives me 9. It's a kind of poor looking 9. I don't know if that's any better. Whatever. Now I got 30 times 200. Looks like I have 3 zeros here. And then 3 times 2 gives me 6. And a couple more. 30 times 200 I just did. So one more, I guess. 30 times A with 3 zeros after it. So I have 3 zeros and 1 more 0, so 4 zeros total. There they are. And 3 times A, well, A represents 10, so 3 times 10 is 30. And 30 in base 16 is one group of 16 with 14 left over. And the way I write 14 is with an E. So when I'm doing the intermediate algorithm, I want to show each of these partial sums. Yeah, sure, let's call them that. Now I want to add these all up. So E plus a whole bunch of zeros leaves me with E. See if I can add this second column here. A 1 and a 6 and a D. Well, D represents 13, and 1 and 6 is 7. 7 and 13 gives me 20. And the way I write 20, maybe this should be in a different color, so it's easier to keep track of. I had that E from the first column. And then 20 when I add up this second column, but 20 in base 16 is one group of 16. So I'll carry a 1 over here to this third column with 4 left over. So I'll throw down a 4 right there. Now adding up the third column, I got a 1, a 4, a 2, and a 9. Well, 2 and 9 gives me 11. 4 more gives me 15, and 1 more gives me 16. The way I write 16 in base 16 is I say it's one group of 16 with 0 left over. Adding up the fourth column, I got a 1, a 4, and a 6. 4 and 6 is 10. 1 more is 11. The way I write 11 in base 16 is with a B. And then this fifth column here, did I do that right? Yeah. This fifth column looks like I have nothing carried over, and then this 1 and this E, so that adds up to F, and then in my sixth column, just this 1 right here. So I think my answer is 1FB04E in base 16, so I can write a little hex here at the end. And then nice, I guess, if there's anything nice about this problem is that the next problem is the exact same number, so I can kind of check that. I do that multiplication again, but with the lattice method, all right? So with the lattice method, the setup is a lot of the problem. A2, 3, F, I'm going to write as column headings, and then 3, 2, I'm going to write as row headings. And then I'm going to set up this lattice, which is kind of a little grid. And I'm going to fill in each of the boxes in my lattice, in my grid, by doing multiplication. And then I'm finally going to add along the diagonals. What diagonals, you ask? These diagonals. Okay, so let's get to putting these numbers in here. F times 3, well, as we have from above, F represents 15. 15 times 3 is 45. 45 in base 16 is 2 groups of 16. That's 32 of the 45. So that leaves me with 13 down here. I don't care whether you write 13 or D here. Doesn't matter to me. If you want to write a 13 here, that's fine too. F times 2, well, 15 is F, times 2 is 30. 30 in this base is 16 with 14 left over. So 1E, and again, you could write a 14 there if you prefer. 3 times 3 is 9, I'll write that as 0, 9. 3 times 2 is 6, write that as 0, 6. 3 times 2 is, again, 6. 2 times 2 is 4. A times 3 is 30, and the way I write 30 is 1 group of 16 with 14 carried. 14 I write with an E. And 2 times A is 20. The way I write 20 is 1 group of 16 with 4 carried. And then I add along these diagonals. So on this first diagonal, I just have this E here. And then I got D plus 1 plus 6. Well, D is 13. And 7 more gives me 20. And the way I write 20 is I say it's 1 group of 16 with 4. There's the 1 that I carry with 4 left over. And I'm going to add this column. I got 1 and 9 gives me 10. 2 and 4 gives me 16. So the way I write 16 is I carry 1 into the next column, or diagonal, I guess, and leave 0 behind. 1, 6, and 4 gives me 11. The way I write 11 is with a B. 2E and, 0E and 1 sum to F. And I have this 1 here. And you'll note that my number here, 1FB04E, is the same number I have up here. Rather than rewriting, I'll just throw a little check mark by it. Now I'm feeling good about the multiplication that I've done. One more problem on this quiz. We got to do division in a different base. Now we're in base 5. My suggestion for doing division in base 5 is to first do a bunch of multiplication. Multiply this 4, 1 here by each of your 1-digit numbers in that base. So do 4, 1 times 1. Maybe you don't need to do that one. 4, 1 times 2, 4, 1 times 3, and 4, 1 times 4. What about 4, 1 times 5? There is no 5 because I'm in base 5. So let's multiply. 4, 1 times 1 is obviously just 4, 1. 4, 1 times 2, well, 1 times 2 is 2. 4 times 2 is 8, but I'm not going to write 8 because I'm in base 5. So I'm going to carry 1 group of 5 and leave 3 behind. 4, 1 times 3. 1 times 3 is 3. 4 times 3 is 12, which I write as 2, 2 in base 5. 4, 1 times 4. 1 times 4 is 4. 4 times 4 is 16, which I write as 3, 1. So I'm going to do this multiplication first so that I can reference it later on. I'm using the scaffold method, so the way I set up the scaffold method is, all right, 4, 1 here, and 2, 1, 0, 2, 3, 2, 3 here. And then I'm going to take out chunks. So what I'm saying is I'm going to take out some number of 4 ones. I'm going to think about it as I have this many of something, and I'm removing groups of this size until I use up all of these. So really what the question is asking me is how many groups of this size can I make from this amount? Well, it's hard to know because this is a base 5 number. You're not too familiar with it, but what I can do is I can reference up here. And I can say 2 groups of 4, 1 uses up 1, 3, 2. So 1, 3, 2 with 4 zeros after it would be 2 with 4 zeros after it groups. 2 with 2, 0, 0, 0, 0 groups of 4, 1 use up this many. So that's a pretty large chunk. You have some freedom in the number you put here. You can put any number you want here as long as the product of this number and 4, 1 is less than this amount. This is a pretty large number because I'm trying to get rid of as many as I can here. I'm going to do my subtraction. Subtracting with the zeros in there is really easy. But here's a little bit trickier. I want to borrow from this 1, which turns this into a 0, makes this a 5. 5 minus 2 is 3. This is now a 0. I can't do 0 minus 3, so I'll borrow from this guy. I get 5 in addition to this 0, leaving me with exactly 5. 5 minus 3 is 2. And since this is now a 1, 1 minus 1 is 0, I don't even have to write it. And now I repeat. I do the exact same thing, except instead of trying to use up this many, I'm trying to use up this many. So what's another good chunk size I can do? Well, if I stare up at my list, 2, 2, 3, with 3 zeros after it, is a number slightly smaller than this guy. It's a pretty big number. 3 with 3 zeros after it gives me this amount. But if I use that chunk size, I'll use up a lot of what I have left over. Let's subtract to see how much we will have left after we use up that many. Again, I'll have to borrow. This turns into a 2. This turns into a 7. 7 minus 3 is 4. And these all go to 0. So I have this many left. Looking back up at my list, if I wanted a 4, 1, 0, 0, I would be using a group of 1, 0, 0, because 1 times 4, 1 is 4, 1, and then tack on 2 zeros. And if I pick that amount, then when I subtract, I don't have too many left, only 2, 2, 3 left. You stare up at your list, and you're like, whoa, 2, 2, 3, that's exactly 3. So use up 3 more groups of size 4, 1. I'll get no remainder, which is a good thing because it told me there should be no remainder. And to figure out my answer, all I got to do is sum these numbers over here. And yeah, you add them up in base 5, but because of the way I did this, the most efficient method, taking out the biggest chunks possible, I shouldn't have any carries. And so when I go through and add these up, I get 2, 3, 1, 0, 3. Remember that you're in base 5. And that right there is your answer. And I guess that ends this quiz here.